Hello everyone, welcome to our course, Local Buckling of Beams, Basic Principles of Steel Structure. Now here is the content, 3.3.1, Local Stability of Compression Flange, 3.3.2, Local Stability of Wipe, 3.3.3, Design Criteria and Preventive Measure. First, local stability. The thickness of flange is much smaller than the height of the cross-section, and the stress gradient along the thickness of the flange is not large. As uniform pressure plate, in order to give full play to the strength of the material, a certain thickness of steel plate is used. Make the critical stress sigma CR is more than the yield point of the steel. Considering the plasticity of the beam flange, the plastic coefficient eta is introduced. The method of limiting the width-thickness ratio is adopted to ensure the stability of the compressed flange plate. Now, the general expression of the local instability critical stress is as the following 3.29. If E equals to 2.06 plus 100,000 millipar, mu equals to 0.3, sigma critical could be expressed as the formula 3.30. T is the thickness of the pressure plate. B is the width of the compression plate. K is the stability factor of the rectangular plate. For I section, the value of B is shown in figure 3.10a. For box section, the value of B is shown in figure 3.10b. Now, the box-shaped section, K equals to 4, eta equals to 0.25. Width-thickness ratio is expressed as the formula 3.31 for I-shape flange, T-shape flange, and flange of overhanging part of box-shaped section. K equals to 0.425, eta equals to 0.25, C equals to 1. Width-thickness ratio could be expressed as the following 3.32. In elastic design, width-thickness ratio could be expressed as the following 3.33. Now here is a pure bending action. As shown in figure 3.11, if the wipe is simply supported on 4 sides under pure bending, if the wipe is too thin, when the binding moment reaches a certain value, the web will buckling and binding compressive stress. Alpha could be expressed as the formula 3.34, and beta could be expressed as the formula 3.35. Now, the value of buckling coefficient K depends on the ratio alpha of the maximum and minimum pressure on the edge of the plate and the length width ratio beta of the plate. Several corresponding equations could be expressed as the formula 3.36a to 3.36c. The relationship between K value and beta is shown in figure 3.12. Now for I-shaped section, it usually has flange thicker than wipe, which restricts the rotation of wipe edge. Considering the transient effect of flange multiplied by the elastic embedding coefficient Kc, when alpha equals to 2, Kc equals to 1.61. Bring it into formula 3.36a, we can acquire the formula 3.37. As the second, uniform shear action. As shown in figure 3.13, the part between the transverse stiffeners of the beam web is a rectangular plate supported on 4 sides. The four sides are subjected to uniform shear forces and are in a pure shear state. The principal stress in the plate is equal to the shear force at an angle of 45 degrees. The principal compressive stress can cause the buckling of the buckling along about 45 degrees, perpendicular to the direction of the principal compressive stress. According to Formula 3.29, tau critical could be expressed as the Formula 3.38. Embedding coefficient Kc equals to 1.24. We can obtain K is expressed as the Formula 3.39, where Lmax and Lmin stand for long and short sides of the plate. For I-shaped section, A and HW replace Lmax and Lmin. Fvy equals to Fy. Substituted into Formula 3.29, we can acquire the expression 3.40. Now the third, unlateral lateral pressure. When unilateral lateral pressure acts, the web may buckling in the area close to the pressure due to large local load or to thin plate. You can see figure 3.14. In this case, the critical stress is expressed by Formula 3.41. C1 is a coefficient related to A to H, and the critical stress unit is Newton to millimeter square. For I-shaped section, TW and HW replace T and H. A to HW equals to 2. C1 equals to 166. We can acquire the expression 3.42. When the flange size of I section meets the ratio limitation, the flange will not local buckling. When the wipe size meets the ratio limitation, single action of shear stress, local compressive stress or bending stress, local buckling of wipe will not occur prior to steel yield. When such ratio is satisfied, local buckling will not occur under the action of shear or bending moment alone. When such ratio is satisfied, local buckling will not occur under the action of bending moment. Now the fourth, complex stress action. In actual wipe of a beam, there are often several stress joint actions at the same time. Under the simultaneous action of uneven pressure on both sides, uniform shear force and lateral pressure on one side could meet the Formula 3.43. Under the simultaneous action of uniform pressure on both sides, uniform shear force and lateral pressure on one side should meet the Formula 3.44. We can see figure 3.15 shows critical stress curve and various distributed force. Now, the design criteria to ensure local stability. The critical stress for local buckling of the plate is not less than the yield strength of the material. The bearing capacity is controlled by the strength as the Formula 3.45. The critical stress for local buckling of the plate is not less than the overall stability of the plate. The bearing capacity is controlled by the overall stability as the Formula 3.46. The critical stress of local buckling of plate is not less than the actual working stress as the Formula 3.47. Now let's look at preventive measure. The main measures to avoid local instability are as follows. Number 1, limit width thickness ratio. The second, set the stiffener. Concretely, you can see when such ratio is satisfied, sigma c equals to 0, the local stability of the wipe can be ensured without the need for stiffeners. The crane beam shall be provided with transverse stiffeners. The second, when such ratio is satisfied, transverse stiffeners shall be provided. The third, when such ratio is satisfied, compression flange torsion is constrained, or another ratio is satisfied, compression flange torsion is not constrained, or according to the needs of calculation, in addition to the transverse stiffener, the longitudinal stiffener should also be arranged in the compression area with larger bending moment. The fourth, wiring stiffeners are required at support position of beam and fixed concentrated load position on flange. That's all. Thank you for your attention. See you next time.